Hello kids, welcome to ICSE Chemistry Hub. Today I'll be teaching part 2 of Electrolysis chapter. Those who have not seen part 1, you can find the link in the description box or you can check the playlist for the first part of this video. Okay, so as we had discussed in part 1 we had discussed about the basic structure of how an electrolytic cell looks like. As you're aware from this diagram itself, we have a vessel which we call as the electrolytic vessel, or what's the other name of it, children? We also call it as a voltameter. So this is the first component that we'll require for electrolysis. The second is we require a chemical compound. This chemical compound is called as an electrolyte. This electrolyte, whenever you're taking, should be in two states. It can either be in a molten state or it can be in an aqueous state. Please note, you can never take electrolyte in a solid state. Clear? So whenever you're doing electrolysis, your electrolyte has to be in these two states. Next, as I had told in my previous video, we need two plates. One plate which is connected to the positive of the battery, and the other which is connected to the negative of the battery. The one that is connected to the positive terminal of the battery gets a positive charge, and we call this plate as anode. And I had asked you to remember it as Pa. So positive terminal is called as the anode, and the one that is connected to the negative terminal will get a negative charge. As you can see, this plate is getting a negative charge because it's connected to the negative terminal. And so we call this as the cathode. And I had asked you to remember that opposites attract. So A to A and C to C. What does this mean? Anions will always move towards anode. What are anions now? Anions are nothing but the negatively charged ions. Opposites attract, so anions will always move towards anode, and cations, which are the positively charged ions, will always move to the opposite terminal, which is the negative charge. So anions will move to anode, A to A, and cations will move to cathode, that is C to C. I hope this much was clear to you in the previous slide. Okay. So what are anions, children? They are negatively charged ions. A to A. That means anions will migrate to the anode. Clear? What are cations? Cations are nothing but the positively charged ions will be called as cations. And we also know it is C to C. What does C to C mean? Cations will always go towards the cathode, which is the negatively charged terminal. Clear? Now, next we had learned that whenever electrolysis is happening, we had learned what is the definition of electrolysis, children. It is a decomposition, or what is the meaning of the word decomposition? It's a breaking of a chemical compound. In technical terms, what do we call those chemical compounds as? We call them as an electrolyte. And what type of current do we use? We always use a DC current. Now you must have seen in the definition, we have seen that we always use a word. What is that word? We say ions are formed when electricity is passed through it. And what is step number 2? Step number 2 that happens is here, the ions need to get discharged. What is the meaning of the word discharge, children? Discharge means these charged particles need to lose charge. Or in other words, they need to become neutral. I hope this is clear to you. So whenever electrolysis is happening, the ions need to get discharged. They will always aim for this process called as discharge. What is discharge? They need to lose charge. That means they need to get neutral. Clear, children? Now based on this, you need to, again, I'll be giving you two short forms to remember. Please remember the word ALO. We can call it allo. And for cathode, do remember the term CGR. Clear? For discharge process, Whenever this will help you for writing the equations. For anode, what is the equation? What is the short form you have to remember, children? ALU. And for cathode, please remember the word CGR. Now the question is, what do these letters stand for? Let us look at the first term. A stands for anode. Okay. So anode, L. L stands for it always loses electron. So at the anode, what process happens, children? At the anode, it will always lose an electron. So when it loses an electron, what process happens here? We have studied in the lower classes. Loss of electron is nothing but oxidation. Clear? So please remember the short form that I am telling you now. What is the short form you have to remember? I'll once again tell it. What happens at the anode? Remember ALU. Clear? What does this ALU stand for? A stands for anode. At the anode, what happens? It always loses electron. Clear? So if someone asks you what happens at the anode, what is anode? Anode is nothing but the positively charged electrode. So what happens at the anode? It always loses electron. And we know whenever there is a loss of electron happening, we call that process as oxidation. Clear, children? So many times it is asked, name the process that happens at the anode. Even if you don't remember anything, just remember the short form ALO. That means anode, there is a loss of electron happening. Because there is a loss of electron happening, we call that process as oxidation. So at the anode, which process happens, children? Always oxidation takes place. And what is oxidation? Oxidation is nothing but loss of electrons. The next process is, remember the short form CGR. What does C stand for? C stands for, as you know, cathode. G stands for cathode will always, what happens here? Cathode will always gain electrons. G stands for gain electron. And whenever it gains electron, which process happens here, children? We call it as reduction. Am I clear? So what does CGR stand for? C stands for cathode. G stands for gains electron. And we have studied in 9th standard that whenever there is a gain of electrons, we call that process as reduction. So at the anode, ALU happens, ALO, anode, loses electron, oxidation. At the cathode, what happens, children? CGR. What is CGR? Cathode gains electrons, and what process happens? It's called as reduction. I hope this much is clear to you. Clear? So let's come to the third point of this. What are anions, children? You have learnt they are negatively charged. If they are negatively charged, where will they start moving? They will start moving towards the positively charged. Opposites attract. So this negative will start moving towards the positive. And what starts happening here? Read the PPT, please. They donate or they lose electron. This is what I said by the letter L. Anode, and what happens at the anode? Anions will lose electron, and what happens to it? It gets oxidized, or what process happens? Oxidation takes place. Come to cations. What are cations, children? As you know, these are the positively charged ions. So if they are positively charged, where will they move, children? They will move towards the opposite terminal. Which is the opposite terminal? These are the negatively charged ions. Clear? So the positively charged ions will move towards the cathode. And we know at the cathode, what process happens, children? There is CGR happening. What is CGR? Cathode gains electron, and always which process will happen? There will be reduction happening to it. So always at the anode, oxidation happens, and with the cations, what happens? They will get reduced. The same thing is written over here. What is an anode? An anode is connected to the PA, positive terminal of the battery. What is cathode? Cathode is connected to the negative terminal of the battery. So the anode, which is connected to the positive terminal, will get a positive charge, and the anions will start moving. What are anions, children? The negatively charged particles will start moving towards the anode. And they will get ALO. They will get oxidized. Similarly, cations, they are the negative terminal of the battery. So, of course, which ions will start coming? The positively charged ions. What are the positively charged ions called as? They are called as cations. And when these cations start moving towards the cathode, what process starts happening here? They start getting reduced. And why does all of this happen? Simply because they want to get discharged. What's the meaning of the word discharged? They want to get neutral. They want to become neutral. Clear? So this is one very common question that is asked in the board exam. Which electrode is called as the oxidizing electrode? Just remember the letters ALO. From this itself, you will understand which electrode, which metallic plate will be called as the oxidizing electrode. It will be the, yes, it will be the anode. Clear? And which electrode is called as the reducing electrode? Just remember the short form CGR. So which electrode is the oxidizing electrode? Anode, because oxidation happened. Why are we saying oxidation happened? Anode, loss of electron. Is this clear? So what happens at the anode? There's a loss of electron, and whenever there's a loss of electron, we call it as oxidation. At the cathode, there will be always G. What does G stand for? Gain of electron. And whenever there is G, that is gain of electron, we call it as reduction. I hope this much is clear to you. Okay. Now you need to remember two words. Clear? You must have learned this in chemical compounds chapter also. Chemical bonding chapter. Clear? This is two words called as electrolytic, dissociation and ionization. Many times in 10th standard, you will hear these two words. Clear? What are the two words, children? One is dissociation and the second one is ionization. Let's look at the first word. What is the meaning of the word dissociation? Dissociate. This word simply means, what is the meaning of the word dissociation, children? It means breaking. Clear? Or can I use the word separation? Clear? Please remember this as a key word. Now, what is electrolytic dissociation? Please remember the first topic, the first point that I'm going to tell you. Electrolytic dissociation. What's the meaning of the word dissociation? Remember it as breaking or remember it as separating. Clear? The first thing that you have to remember is it always takes place in which type of compounds, children? It happens always and always in electrovalent compounds. What is the other word for electrovalent? We also call it ionic compounds. Now, what is, for example, I'll take an example of an electrovalent compound. Let's take the most common example. Which is the most common example? Your common salt that you use at home. That is sodium chloride. Now, this is an electrovalent compound. How did we understand it's an electrovalent compound? The moment you see a metal and a non-metal. Sodium is a metal here. Chlorine is a non-metal here. Na plus Cl minus. Clear? Can you see in this picture? Na plus Cl minus. Already ions are there in this compound. I need not form ions here. Clear? For sodium chloride, ions are already there. Already plus and minus charges are there. But what do I need to do here? I just need to separate the ions. Am I clear, children? So whenever there is a separation of ions happening, ions are already there. I am just separating the ions. What is that process called as? Electrolytic dissociation. Clear? Once again, I'll tell you this. What is electrolytic dissociation? Point number one that you have to remember. It only happens for which type of compounds? Electrovalent compounds. Clear? Why? Electrovalent compounds already have the formation of ions. Clear? What do I need to do? I just need to break these ions. I just need to separate these ions. So, separation of ions is called as electrolytic dissociation. Clear? Come to the next word. What is ionization? Remember this as the key word. What has to happen in ionization? There are no ions that are there in this compound. Clear? So if there are no ions, for sure 110% this would be a covalent compound. So if there are no ions, if I want to pass electric current through it, I have to make them undergo the process of ionization. What is ionization? Ionization is nothing but I am forming the ions first. Clear? In electrovalent compound, I already had these ions. I just needed to separate these ions. Whereas in a covalent compound, what is the problem, children? I don't have any ions. So first, what do I need to do? Somehow, I need to form ions. So the basic difference between dissociation, remember dissociation is nothing but separation. Separation of what? Separation of ions. What is ionization? Ionization is nothing but I am forming ions because there is no ions here. Clear? So dissociation is separation of ions. It will always take place in an electrovalent compound because ions are already there. I just somehow need to separate it. Whereas for ionization, what do I need to do, children? I first need to form ions. It will always take place in a compound which is only made up of molecules. So this does not have any ions. So what do I need to do first? I first need to form ions. So dissociation, separation of ions. What is ionization? Ionization is nothing but formation of ions. So remember these words. Dissociation, breaking of ion. Ionization is forming of ions. Okay. Now many times this difference will be asked to you in the question that why a metal is called as a good conductor. It's called as a conductor. Whereas for any liquid, what is the word you will be using? You will be using, whenever it is liquid or molten state, you will be using the word electrolyte. So you have to understand what is the difference between a metal, conduction that happens through a metal, and when I pass electric current through an electrolyte. Let's have a look at the first point. For example, when I am passing electricity in my home, that flow of electricity, when I am passing it through a copper metal, for example, let's say I have taken copper metal. The conduction of electricity or the flow of electricity happens because of electrons. Clear? The flow of electricity is because of electrons. The word electricity comes from the word electrons. Flow of electricity is nothing but flow of electrons. But when I am taking an electrolyte, I hope you remember, my electrolyte always has to be in two states. Which are the two states? Yes. It has to be either be in the molten state or I need to be it in the solution state. So whenever it is in liquid state, in an electrolyte, the flow of electricity happens because of ions. Clear? So in a copper metal, the electricity is able to pass through it because of electrons. And in an electrolyte, it happens whenever it is in solution state. You have to remember it is because of ions. Clear? Next, whenever I am passing electricity through a copper metal, nothing happens to the parent metal. In this case, nothing happens to my copper metal. For years together, I need not change my copper metal. Clear? There is no breaking. There is no decomposition of the parent metal happening. Clear? But whenever I am choosing an electrolyte, the first line of the definition itself states what happens here. Sorry, there's a no mistake here. What happens here? There is a decomposition of the electrolyte happening. That means, for example, if I take CuSO4 as my electrolyte. Is this an electrolyte, children? Yes. When I mix it in an aqueous state, when I mix it with water, it becomes an electrolyte. Clear? So what happens to this copper sulfate solution? There is a decomposition. What is the meaning of the word decomposition? I told you before, there's a breaking. The copper sulfate compound will break into Cu2 plus and SO4 2 minus. What is Cu2 plus and SO2 minus called as? These are called as ions. Clear? So the first point that you have to remember is flow of electricity happens because of ions in this case, and in this case it happens because of electrons. Secondly, there is no decomposition of the parent metal happening here. Here there is a breaking, or my electrolytic compound will not be the same. It will break. Clear? The third most important point you have to remember is metals can conduct electricity. For example, if I take copper metal. Copper metal can conduct electricity in which state? Solid state. Whereas 100 times I have told you, whenever it is electrolyte, electrolytes can conduct electricity only in two states. Molten state or solution state. So this is the basic difference between a metal and an electrolyte. Here, one of the famous question that is asked. Copper is a good conductor. This is one of the board questions that was asked in one of the years. Copper is a very, very good conductor of electricity, but it is a non-electrolyte. Clear? So copper, as we know, it can conduct electricity, but in which state does it conduct electricity? Yes, it can conduct electricity in the solid state. But whenever we talk about electrolyte, clear, electrolyte compulsorily have to be either in the liquid state or in the molten state. Is that clear? Second thing, as I told you before, copper metal does not undergo chemical decomposition. It does not break into anything else. It remains as copper. Whereas the example I just now gave you, copper 2 sulfate. What is copper 2 sulfate? It is nothing but CuSO4. What does it break into? It breaks into Cu2 plus, which is the valency of copper. SO4 2 minus becomes sulfate. These two are called as ions. So what has happened to this compound, children? CuSO4 has undergone a decomposition. It has broken down to give me Cu2 plus SO4 2 minus. Hope this is clear to you. So we are starting with the first electrolysis of grade 10. It is nothing but the electrolysis of, as I told you, whenever I am taking an electrolyte, my electrolyte compulsorily have to be either in the molten, what is the other word for molten? Fused. I am going to do the electrolysis of the first compound that is given in your book, that is lead bromide. Now, what is the formula for lead bromide, children? We know Pb is plus 2. The valency of lead is Pb plus 2. Bromide is Br minus 1. Crisscross the formulas. What will be the formula for lead bromide? PbBr₂. So this is the first thing you should know. What is the formula for lead bromide? PbBr₂. And this is how the setup looks like. You have molten lead bromide. You have taken it into a voltmeter or a crucible. I have placed my electrolyte, which is my electrolyte, molten lead bromide. And one I have connected to the positive terminal of the battery. The one that is connected to the positive terminal, I know it is the anode. The one that is connected to the negative terminal, it is called as the cathode. Am I clear till here? Okay. So please remember, what is the electrolytic cell I have taken? What is my voltmeter? It is nothing but a silica crucible. Your silica crucible looks something like this. This is how a silica crucible looks like. Now the question that will be asked is, why only I took silica crucible for my electrolytic cell? As I told you, whenever you are taking an electrolytic cell, it itself should not start conducting electricity. So the first reason why I preferred silica was that it is a non-conductor of electricity. It does not conduct electric current at any cost. Clear? Secondly, it is non-reactive, which is what we want. We do not want it to react with lead bromide, especially bromine. Can you tell me what is the color of bromine? It is reddish brown gas. Is this clear? So reddish brown color gas. It is a very, very reactive substance. Clear? It is very, it will try to damage the crucible. So it is a bit corrosive in nature. So we prefer such substances that are non-reactive, which will not react with the bromine vapors. So point number one, why we choose it is, it's non-reactive. It is non-conductor of electricity. And as you can see in this diagram, I am heating the apparatus. So of course, it should be able to withstand very, very high temperatures. So children, why did I prefer a crucible made up of silica? It is non-reactive. One, it does not react with the bromine vapors because bromine is a very, very reactive gas. Secondly, as I told you, it should not start conducting electricity on its own. And because I am heating it, it should not break at that high temperature. It should be able to withstand very, very high temperature. Clear? So we will start with the reaction. So I have taken lead bromide. What is lead bromide, children? It is nothing but PbBr₂. Clear? I started passing electric current through my electrolyte. Now, as you are aware, I have two electrodes. I have anode. What is anode, children? Anode is nothing but the positive terminal. Pa, positive terminal. Cathode is nothing but the negative terminal. Clear? Okay. So this PbBr₂, can you tell me how is it going to break? I'm just writing it here. PbBr₂ will break into, how will this substance decompose? Pb, what is the valency of lead? Pb2 plus how many bromine ions are there, children? Can you see the number down is 2? Write 2 there. Br1 minus. So Pb2 plus 2 Br minus. What is this Pb2 plus called as? This will be my cation. And we know cation is nothing but C2C. So where will my cations go? Can you see here? My cations will start moving towards the cathode. And which is the anion, which is the negatively charged ion I have? My anions are nothing but bromide. So where will this bromide ion start running? My bromide ions will start running towards the anode. C to C, A to E. Is this diagram clear to you, children? Cations will move towards cathode. Anions will move towards anode. Clear? So can we go ahead with the reaction, children, now? This is how you will write it. PbBr₂. First, you will write the equation. Pb, what is the valency? 2 plus. How many bromine ions are there? 2. We know the valency of bromine is 1 minus. Clear? So I have one cation and one anion in my equation. Clear? Now I will start. These are very, very important electrolytic reaction. I will first start with my cathode. When I say cathode, cathode is having what charge, children? It is having negative charge. Clear? And we also know it is C to C. Clear? And we have learnt a full form called as CGR. Do you remember this? Cathode. What is the charge on the cathode plate? It is negatively charged. What was the first short form I gave? C to C. Clear? Cations will move towards cathode. So can you tell me which is the cation in this? What are cations? Cations are nothing but the positively charged ions are called as the cations. So what will be the reaction at the cathode? Cations will come to cathode, C to C. So amongst this, Pb2 plus will come towards the cathode. Now they want to get discharged. What's the meaning of the word discharged? They want to lose their charge. Clear? So how can they lose their charge? Pb2 plus If it is a plus here, close your eyes and write a plus here. If it is a plus here, put a plus here also. How many electrons here? 2. I will also write here 2 electrons. Am I clear? At the cathode, it is C to C. That means cations will come to cathode, which is what they have done. Cation has come to cathode. If it is a plus here, put a plus here. Whatever is the number, copy the number like that only. What will it form? It will become neutral lead metal. Am I clear? What is the product that is formed at the cathode, children? Lead metal. And please remember the color of lead metal. It is nothing but silvery grey. Am I clear? So it is Pb2 plus. At the cathode, what has come? C. That is cation. If it is a plus here, close your eyes and put a plus here. 2 electrons. It has plus. Here also plus 2 electron. It has become discharge. What is the meaning of the word discharge? It has become neutral. Now it has become neutral lead metal. And what is the color of lead that you have to remember? Lead is silvery grey color. So anytime in the board exam, they ask you, name the silvery grey metal that is deposited at the cathode. Always remember, silvery grey is nothing but lead. Now we have the reaction at the anode. What is the word we had remembered? A to A. Clear? So which ion will run and come towards the anode? It will be Br1 minus. Anions. Anions are negatively charged. They will run and come towards the anode. Opposites attract. Anions will come towards, minus will start coming towards the positive plate. If it is a minus here, close your eyes and put a minus here. How many is it? What is the charge here? 1 minus. I will also put here 1 electron. Clear? Br1 minus, minus 1 electron. It gives me Br. It becomes discharged. What is the meaning of the word discharge? It loses its charge. Now there is a problem with this Br. What's the problem with Br? This Br alone is very, very unstable. Clear? So what it does? Because this Br is very, very unstable, it immediately combines with another Br and it forms Br2 molecule. Clear? Now this Br2 molecule is a gas. So what will be the color of bromine? It is reddish brown color gas. What will you observe at the anode, children? You will observe reddish brown color gas. Clear? So you have to remember these observations. C to C. At the cathode, what will be deposited? My metal will be getting deposited. Which is my metal here? Lead. What is the color of lead? It is silvery grey in color. Whereas anode, anion will come. Br1 minus has come. If it is a minus here also. Whatever is the number, you just copy it. And they become discharged. What's the meaning of the word discharge? They lose their charge. Clear? But this one bromine is highly unstable. So it immediately combines with another bromine and it forms bromine molecule. So what is the color of bromine molecule? Can you see here? What is the observation at the anode? You will find reddish brown color fumes. This is an observation that you need to remember. So what will you observe at the cathode? At the cathode, you will get lead metal. What is the color of lead metal? Silvery grey lead metal is deposited. These are the words that you should use. At the cathode, silvery grey metal deposition. What will you observe at the anode? What is the meaning of the word observation? What you will see at the anode. What will I observe at the anode? My gas that is released is Br2. Clear? What is the color of bromine? Reddish brown color fumes of bromine. Clear? So this is all about the electrolysis of lead bromide. So here I am stopping with part 2 of electrolysis. Stay tuned for the next part, which is going to be electrolysis of water and some important compounds. If you have liked my video, please do like and subscribe and stay tuned. Keep learning.